Now today we are going to study about resistivity. Resistivity or specific resistance. Resistivity or specific resistance of a conductor. Okay. So till now we have studied about resistor, right? So what is a resistor? Resistor is a component. It is a physical component which is having the property called as resistance. That means to limit the flow of current. Okay. Please don't get confused with resistor, resistance and resistivity. Resistor is a component. Resistance is a property of that component is called resistance. Resistor is a physical component. Okay. And resistivity. So we'll study about resistivity today. Today we'll study about this. Okay. So consider one conductor. So I am taking one conductor. So what is a conductor? Conductor is a material which allows heat or electricity. Means the material in which the electricity can pass through it. So that material we call it as a conductor. Okay, so that we call it as a conductor. Consider this is a conductor which is having a length L. So which is having a length L and resistance R. So last class only I told capital R is the letter we are going to use for the resistance of a resistor, right? So R is the resistance and L is the length of that conductor and which is having the area A. Okay. Now at constant temperature, the resistance of a conductor is directly proportional to, at constant temperature the resistance of a conductor is directly proportional to length and inversely proportional to area. Okay, at constant temperature the resistance of any conductor is directly proportional to length of the conductor and area of that conductor. So from this and this I can write R is directly proportional to L by A. Can I write like this? Yes. So I want to remove this direct proportionality. So for that I have to put one constant. So that constant is rho L by A. Okay. By removing this I am putting equal and replacing this with a constant called as rho. So this is called as a rho. This is called as rho. This symbol is called as a rho and this is a resistivity. This is the resistivity of a conductor. Okay, clear? So what is a resistor now? Resistor is a physical material. Resistance is a property of that material and resistivity rho is the constant. Rho is a constant for a material. Here resistor, resistance, resistivity. Okay. So this is a rho. Rho is called as a resistivity of a conductor or a material or whatever. Okay, clear? So resistivity R rho is equals to, so from this I can write rho is equals to cross multiply. I will get rho is equals to R A by L. Am I right? Rho is equals to RA by L. This is the resistivity of conductor. Understood? So this is the resistivity of a conductor. Rho is equals to RA by L or AR whatever by L. R is the resistance, A is the area of cross section and length L is the length. Okay. So from this I can define a resistivity of a conductor. Rho is equals to resistance of that conductor when the conductor is having L is equals to 1 and A is equals to 1. That means the conductor is having a 1 meter length and 1 square centimeter area. So that by definition, what is the definition? If in the exam they asked for define resistivity and give an equation and the so you have to write resistivity of a conductor is defined as the resistance of that conductor when the conductor is 1 meter length and 1 square centimeter area, and the equation is rho is equals to Ra by L. So this is the resistivity of any material, a resistivity of a conductor. Okay. So with the example this we can solve one problem. Okay. Take down. The problem is the resistance of a wire of length 1 meter. The resistance of a wire of length 1 meter and of diameter 0.12 millimeter and of diameter 0.12 millimeter is 40 ohm. What is the specific resistance? What is the specific resistance? So what they have given? They have given what and all they have given? The resistance of a conductor, right? So the resistance of a conductor is the resistance R is equals to 40 ohm and length they have given. What is the length? Length is length they have 1 meter. Length is 1 meter and diameter D 0.12 millimeter, right? So what is the formula? Rho is equals to Ra by L, right? Ra by L, but instead of A they have given diameter D. So what is A? A is pi R square, right? Pi R square, or else I can write this as pi D square by 4. Can I write? Yes. So write rho is equals to R40 into D, how much they have given? 0.12 into 10 to the power minus 3 whole square divided by 4L, 4 into 1. Find out. What is the answer? So answer is 0.45 into 10 to the power minus 6 ohm meter. 0.45 into 10 to the power minus 6 ohm meter. This ohm meter is the unit for resistivity. Okay, clear? You understood what is resistivity? So resistivity by definition. Actually resistivity is a constant. Okay, resistivity will be always constant and it is different for different resistances and different conductor, whatever. Okay, resistivity is a constant. What is resistance? Resistance is property of resistor. Okay, resistor is a component which is having resistance and resistivity. Clear? Where resistivity is a constant. Please don't get confused with resistor, resistance and resistivity. These three terms are different. Understood? Fine. So now we'll study about resistors in detail. Okay. So I told. Now how we are going to represent resistor in an electronic circuit, or pictorial representation of resistor is like this. So this is R, right? This is a pictorial representation of a resistor. So this resistor is having two types. Resistors are classified into two types. Those are fixed resistor and variable resistor. Fixed resistor and variable resistor. What is a fixed resistor? The name itself is indicating that the resistor means the resistance of the resistors are fixed. That means what? While manufacturing the resistor, they have fixed the resistance. They have fixed the resistance, the value of the resistance they have fixed. We cannot change the value of the resistance manually. Okay, for example, in an electronic circuit, we need 10 ohm resistor. Okay, we need 10 ohm resistor, but I have 20 ohm resistor. So what I have to do? I can't connect 20 ohm resistor in my electronic circuit. So I want 10 ohm resistors only. So I have to replace 20 ohm resistor with 10 ohm resistor. For example, you have connected 10 ohm resistors. So while doing your experiment, you have to increase the value of your resistance. So what you have to do? You have 10 ohm resistor, but you want 20 ohm resistor. You want to increase the value of that resistance. So in those cases you can't handle or you can't maintain that circuit with 10 ohm resistor only. You have to replace this resistor. You have to remove this 10 ohm resistor and you have to connect one more resistor, 20 ohm resistor. Okay, so this is the fixed resistor. Whereas in variable resistor, you can vary the value of the resistance manually. For example, you have connected 10 ohm resistor. So while doing experiment, you want 20 ohm resistor. That means no need to replace the resistor. You can change the resistance value there itself. That means it will have from 0 to 20 ohm. Like that it will be. So the resistance value will vary from 0 to 20 ohm. So you can fix the value of resistance for your desired. Right. So for example, if you want 50 ohm resistor, you can connect it this for 50 ohm. So the minimum value is 0 ohm and maximum value is 10 ohm. So in this resistor, so if R is equals to 10 ohm means the value of that resistance is fixed. You can't change this value. If you want 20 ohm resistor, you have to remove this and you have to connect 20 ohm resistor. So this is fixed resistor and this is variable resistor. So we are going to represent the representation of fixed resistor and variable resistor is also different. So we are going to represent a resistor like this is the fixed resistor. So this is a pictorial representation for fixed resistor. Whereas for variable resistor, the same resistor we write like this and we make an arrow like this. So this is the pictorial representation for variable resistor. Clear? Fixed resistor and variable resistor. And there are so many types in fixed resistor. So those are carbon composition resistor, metal mount resistor, wire wound resistor, and SMD surface mount resistor, and here presets and rheostat variables. So there are so many types of resistor. So we'll study about those resistors in next class. Okay.